Like my notes pages and the videos, are those showing up okay for you guys? I'm hoping. Okay, I hope this is working out. My goal is to make this the class experience positive for you guys, a good experience, and I know sometimes we have technical difficulties in the lab, so that happens, and I apologize. I'll try to minimize the pain related to that. Let's see. All right, okay, so we're going to continue on in Chapter 3. So this is going to be Chapter 3, Section 2, which is all about Z-scores. So last time on Monday, we talked about the mean and the standard deviation. The mean is a numeric summary that tells us where the center of our data is. What's another interpretation for the mean that we talked about? I think I heard someone say it, the balance point in our data. So if you can think of, imagine having our dot plot or a histogram, where would we draw the fulcrum on a seesaw? That would be the mean, right? So we have the mean as our balance point. And what does the standard deviation tell us? The standard deviation tells us it's a numeric summary for the spread in our data. Okay, and we can think of it as the square root of the variance. And the variance can be thought of as the quote-unquote average square distance, if I can spell. Average square distance from the mean. And I have average in quotes because instead of dividing by n, we divide by what? N minus 1, right, okay. Okay, so these are combined in a concept known as the Z-score. Okay, the Z-score can be thought of as the distance from the mean measured in standard deviations. Okay, and these are useful because oftentimes we are in a situation where we don't have a whole lot of, context, or we don't know a whole lot about the data itself. Okay, so there are some numeric figures that are already very familiar to us. We just kind of have an intuitive sense. So if I tell you I saw a guy and he was 6'5", intuitively you would say, oh, that person is tall. That man is tall. 6'5" is tall. Or something like that. So we have an intuitive sense. Now, imagine you went to the doctor and they want to get some blood work done. So they draw some blood and they send it to the lab, and and the doctor says, I want, and we're going to just make a fictitious thing. And the doctor says, I want to get your XYZ levels measured. And so they send your blood to the lab, and the lab comes back, and the doctor says, your results came back, and your XYZ level is 242, okay? And you say, well, what does that mean, okay? Now, your doctor will probably answer you in a straightforward way, but it's possible that the doctor says, okay, well, just so you know, the average XYZ score is 150, okay? And then you ask, well, so all we know right now is that 242, your score is higher than average. But we don't know, is this really high above average, or is it not that high above average, okay? And so then the doctor can say, well, we might consider the range of normal. So there's, we have a few scenarios. The doctor can say the range of normal for XYZ is anywhere from 120 to 180, okay? And in that case, you would say, oh dear, my XYZ is very high at 242, and the range of normal goes from 120 to 180. This is bad news. On the other hand, if the doctor says, well, we consider, the average is 150 and range of normal is anywhere from 0 to 300, then you could breathe a sigh of relief and you'd say, okay, well, 242 is higher than average, but it's still within the range of normal, okay? So that's, so we can talk about what the range of normal is. The doctor can also just report to you a Z-score, okay? And we kind of have these guidelines where we say if the Z-score is above 2 or less than -2, that can be considered unusual, okay? So Z-scores over 2 or less than -2 are unusual, and Z-scores over 3 or less than -3 are highly unusual. Okay? Oops. Okay, so Z-scores over 2 or less than -2 are unusual, and over 3 or less than -3 are considered highly unusual. So, so instead of saying, your score is 242 and the range of normal is, 120 to 180, the doctor can just say, you have a Z-score of plus 3.5, okay? And because you now know that scores over 3 are highly unusual, having a score of 3.5 would be, very, could probably cause for much concern, okay? The formula that we can use for a Z-score is going to be x minus x bar divided by s. And I think this makes sense. X minus x bar, the numerator is our distance from the mean, right? And rather than just reporting the distance from the mean as is, saying your distance from the mean is x minus x bar, we want to express it in standard deviations. So, we divide by s to report that distance in standard deviations. Okay, this is not that unusual of a concept. I could say, I'm just making stuff up, but I could say the width of this projection screen is 120 inches, and internally in your head, you can do 120 divided by 12 inches per foot. The width of the screen is 10 feet, something like that. So all we're doing is we're just saying, our distance from the mean is this, and we're going to just divide by the size of the standard deviation to get that distance expressed in standard deviations, okay? I gave you, on the previous slide, I gave you some guidelines about what's unusual and what's not. This stems from what we call the empirical rule, okay, which is based on a unimodal and symmetric distribution. So something that looks kind of like this. Sorry, this is such a terrible drawing. And the guidelines, the empirical rule says something like about 68% of our data is within 1 standard deviation of the mean. About 95% of our data is within 2 standard deviations of the mean. And about 99.7% of the data is within 3 standard deviations of the mean. Okay? And, you know, just to illustrate, we can say the heights of adult men in the United States is unimodal and symmetric. The mean height, so what would you say the average height of a male in the US is? Yeah, the mean height is about 5'9" or 5'10". So we will say, just for simplicity's sake, we'll say 5'9", so 69 inches, okay? And for simplicity, we'll say the standard deviation is 3 inches, okay? Now, it's not exactly this. It's probably, 69.5, and standard deviation is probably just a fraction over 3 inches. But just for simplicity's sake, we'll use these nice round numbers, okay? And so what this says is that, within 1 standard deviation of the mean. So that would take us, so 1 standard deviation above the mean would be what? 69 plus 3 inches, 72 inches, okay? And 1 standard deviation below the mean would be what? 66 inches, okay? And so what our empirical rule says is that about 68% of US adults are between 66 inches and 72 inches tall. All right, and we can extend this, and so for U.S. males, 1 standard deviation above and below would be 66 to 72. Being 2 standard deviations within the mean, that would take us down to what and what? 63 to 75. And 3 standard deviations, this would be 60 inches to 78 inches, okay? And I hope this, not exactly, but this should match kind of our intuitive sense. 63 inches is 5'3", 75 is 6'3", okay? And it says about 95%, so, about 1 in 20 males, adult males, are outside of the range of 5'3" to 6'3", but overall, about 95% are between 5'3" and 6'3". And then, about 99.7, so the vast majority would be between, 5 feet tall and 78 inches would be 6'6". So, almost all U.S. adults are between 5 feet. U.S. adult males are between 5 feet tall and 6'6". Of course, there are some people outside of that range, but that range of 5 feet to 6'6" covers the vast majority. Okay, and this could be applied to almost any unimodal and symmetric distribution. And this is our empirical rule. Are there any questions on this? Okay. So going back to Z-scores, someone who is 78 inches tall, this person is would have a Z-score of +3. This person is 3 standard deviations above the mean. This person has a Z-score of +3. So let's, I'm going to just flip to the next slide. Z is equal to x minus x bar over s. So, you know, a man who is 78 inches tall, so 6'6", you know, has a Z-score of +3, okay? And that's because the mean height of men is 69 inches. Standard deviation of male height is 3 inches, okay? So our Z is x 78 minus x bar over s. So we have 78 minus 69 divided by 3, 9 over 3, Z-score of +3, okay? And, you know, anything, any other height, we can say a man with a height of 67 inches has a Z-score of what? All right, and this is where we would use the clickers. Yeah, okay, so our Z-scores would be, Z would be 67 minus 69 over 3, negative 2/3, so negative 0.6667, something like that. Okay, and so Z-scores, they allow us to, they kind of create this standardized ruler, right? So, you know, if we're talking about XYZ scores in your blood, okay, you could say, well, my XYZ score is 242 and my HIJ score is 148 and my JKL score is 7. Okay, are these good or bad? Okay, well, instead of having the numbers reported directly, we can turn everything, standardize the scores, or turn everything into Z-scores, okay? And then we have a common scale that we can use to compare measurements that are coming from, you know, different scales, okay? So we can use, so we can, quote, standardize scores by turning them into Z-scores. And this gives us a, quote, common way to measure and compare values coming from different populations. All right, so we could, I could say, what do you think is more unusual? A man who is 6'5" or a woman who is 6'2"? And what would you say? Yeah, you would say a woman who is 6'2", and that's just because from your intuitive sense, you'd say, well, a woman who's 6'2", that seems more unusual than a man who is 6'5". However, if we were talking about something else, what's more unusual? A person with a test score of this, or a person with a test score, a different test score with this. You can turn them into Z-scores, and so rather than having to rely on your own mental intuition about the center and spread, you can just use a Z-score. And we could say the man who is 6'5" has a Z-score of, plus 2.5. The woman who has who is 6'2" has a Z-score of plus 3. we could say, oh, well, the woman's z-score is 3, the man's z-score is 2.5, therefore the woman's score is more extreme. Her height is more unusual. Okay? So, you know, z-scores that are further from 0 can be considered more unusual than other z-scores. Okay, so z-scores Okay, so in your homework you'll have some exercises covering z-scores, making comparisons of measurements and whatnot for z-scores. Okay, and again, the z-score is just a way for us to combine the information that we have about the center and spread of a data set to then assign a value to each measurement and say this measurement is unusual or this measurement is not that unusual. All right. We'll talk about the other numeric summaries. So I said numeric summaries, we have the mean and standard deviation, which might be preferable for symmetric distributions. If we have skewed distributions, the numeric summaries that we could use are the median, okay, and range and IQR. Okay, and these could be considered perhaps preferable in situations with skewed data. Okay. All right, the median, so we can think of the mean as the balance point in our data. The median can be thought of as the halfway point of our data. Okay, this is the spot where half of your data is larger, all right, and half is smaller. So spot where half of the data is smaller and the flip side is and half are larger. Okay. So, you know, when you have a large data set, or just any kind of data set, to find the median, what you're going to do is you're going to place the values in order from least to greatest. Okay. You're going to count how many values you have. And then you're going to find the spot where half are smaller and half are greater. Okay, so, you know, so example, let's say you have 16 numbers. Okay, so you arrange these, you're going to arrange these in order from least to greatest. And basically, if you have 16 numbers, you're going to have 8 values over here and 8 values over here. Okay, and so basically your, if you arrange these, if you numbered these, the 8th value and the 9th value are going to separate, are going to be right here in the order, okay? And so your median is the spot in between, is halfway between these two values. Okay, so you just, average the middle two numbers. Okay, so, whatever your 8th number is and your 9th number is, you would add those two together and divide by 2. Okay, that's if you have 16 numbers. And that could be extended to, anything. And then the other case that we have to worry about is if we have an odd number of numbers. Okay, so if we have 17 numbers, I'm going to flip to the next slide here. So let's say we have 17 numbers. So with 17 values, again, you arrange these from least to greatest. Okay, and you'd say 17 divided by 2 is 8.5. So what we would do is we would find 8 values over here. There's going to be 1 value, and then 8 values. Okay? And then this 1 value that's in the middle, this is your median. Okay? So I think that's straightforward enough. So finding the median, it involves arranging them from least to greatest, and then you say find the spot where half are bigger and half are smaller. Okay. Let's, just a quick comparison between the mean and the median, right? Let's, these are, they're both numeric summaries for center. The conceptual idea is that the mean is the balance point. The median is the halfway point. Okay? But they both give you an idea of where the center, or your typical values in your data are. The mean is affected by extreme points. The median is not. Okay? So what that means is that when you have skewed data, the mean gets pulled out in the direction of the skew. Okay, so for skewed data, pulled out okay, so here's just a kind of a quick illustration. So if this is our data set illustrated by this curve, the median might be halfway, which means like if I were to shade this whole thing, where is the spot where I'm using half of the paint? I don't know, I'm just guessing. Something like right there. This is my guess for the median, okay? the mean gets pulled out in the direction of the skew, where if I tried to put the triangle here, it would tip over. So I have to probably put the triangle over here for it to stay balanced. I don't know, maybe this is not a good example, but so the mean gets pulled out in the direction of the skew in order for this thing to stay balanced. Okay, and I don't know, maybe my picture is inaccurate, but this is the general idea of the comparison between the mean and the median. Okay. Okay, let's talk about these other measures of spread, the range, and the IQR. Okay, so the range, this is a measure of spread, or a numeric summary for spread. And what this tells us is it tells us the distance between our largest and smallest data points. Okay? I think the door just slams. I don't think she was angry. Don't you hate that when you like accidentally slam the door and then you're like, oh, sorry, I didn't mean to slam the door in your face. So we can define the range as the max minus the minimum, okay? So that's the distance between the largest and smallest data points. So the range is obviously going to be affected by extreme values, right? So this is very much affected by extreme values. Okay. On the other hand, we have the IQR, which stands for interquartile range. This is the range of the central 50% of the data. Okay. And so, so this is defined as Q3 minus Q1, or the third quartile, minus the first quartile, okay? And contrary to the range, it is not affected by extreme values. So you can see we have different numeric summaries that some are affected by extreme values and some are not affected by extreme values, and whether you want your values to be your numeric summaries to be affected by extreme values or not depends on the situation that you're in. If in some situations you do want that taken into account, and in other situations you don't, okay? So when we're talking about calculating the IQR, the interquartile range, I probably need to define Q3 and Q1, okay? So if I may, I'm going to flip to the next slide. Q3, our third quartile, or here, let's start off with Q1, our first quartile. This is the spot where 1/4 of the data is smaller. Okay, can also be thought of as the 25th percentile. The spot where 25% of your data is smaller. So with that, Q3 is our third quartile, and what is this equal to? Yeah, our 75th percentile, the spot where 3/4 of the data is smaller. Or the 75th percentile. So, with that, we can also say the median is also equal to Q2, or the second quartile. Okay? And the maximum, our maximum value, can also be thought of as Q4. But, nobody ever calls these things Q2 and Q4. We just say the median, and we just say the maximum, okay? And nobody calls the minimum the 0th quartile. That also seems ridiculous, okay? So, finding the quartiles is rather straightforward. First, find the median. Okay, and when you find the median, that effectively splits your list into two lists. You got the smaller list and you got this upper half, okay? Smaller half and upper half. Okay, so find the median. This splits your values into a smaller half and larger half. Which sounds oxymoronic because halves are supposed to be the same size. You have the smaller half being the values that are less than, I don't know. You guys know what I'm talking about, okay? And then basically you take each half and then you split that in half again, okay? So you're finding the median of each half. So find the quote-unquote median. Of each half, okay? And that will be your quartiles, okay? Okay, all right, so let's just try this out, I think we can do this. So let's say I have 16 test scores. And our test scores are such, okay? And I'm gonna already arranged from least to greatest. Okay, so let's say our lowest score was 51, and then we have a 62, a 66, a 70, a 71, a 74, a 78, an 80, an 81, an 82, another 82, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 85, 88, 90, 92, 96. How many is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, and those are our test scores. Okay, so report to me our 5 values that we want. The min, the Q1, the median, the Q3, and the max. Okay? And this should also give us the range and IQR. I'll have to think of good clicker questions that will be multiple choice. This is not a good clicker question. But we'll start this on the 3rd week. I think it's working. I'll give it, on Friday we'll try one more test run, make sure everything's good to go. Okay, so what is our smallest value, our minimum? 51, right? Okay, so to get our thing, we're gonna find our median. So we have 16 values, so we're gonna find 1, 2, 3, 4, 5, 6, 7, 8. I mean, I could just number these. Okay, and so our median is going to be halfway between 8 and 9, so our median will be 80.5. Q1 is going to be, you know, now that I have 8 values that are smaller than the median, I'm going to find the spot there, and this is going to be Q1. So our median is 70.5. Everyone's good so far? Good, okay. And then we do the same thing for the upper half. So between 85 and 88, so what's that? 86.5, I think. Our maximum, 96. Our range would be 96 minus 51. So what's that? 45. And our IQR would be 86. What's wrong with me? 86.5 minus 70.5. We have an IQR of 16. Okay, yay. That's it for today. I'll post up some homework. I'll post up the solutions for Chapter 3, Section 1, and we'll see you guys on Friday.